Hello everybody, and welcome to the 10.3 practice problems, where I will be going through each one in detail to help you with your exit slip. So let's get going. Number 1 asks you to rewrite the following log equations as exponential equations. So if we take a look at part A, the reason I put part A here, even though it was not in the video for today, it reviews something from last week. So if I'm given log base 5 equals 0.698970 and forever, we want to convert this to an exponential equation. So the first thing we need to ask ourselves is, what is the base? What is the exponent? And how can I rewrite this? So remember, I said pretty constantly in the last video that logs are exponents. So that means that this number must be my exponent, and it looks like this log does not have a base. But when you see a log written without a number, you assume that it is base 10. So if it says log of looks like nothing, you assume that's base 10. So if I want to rewrite this as exponential, the base is 10. The exponent is the 0.698970. That equals 5. And feel free to plug that into your calculator and check that. If you plug in 10 to the 0.698970, and I'm doing that right now just to make sure myself, I got 4.99999 repeating, which is pretty much 5. So this is my equation written as an exponent. Part B, ln of 4/7 equals negative 0.559616. Whenever you see an ln, again, that is really a log. However, the base of an ln is e and not 10. You assume it's an e. So even though this says ln, you're still thinking to yourself, logs are exponents, which means that this is my exponent, and my base must be e. So if I was to rewrite this as exponential, we would have e to the negative 0.559616 is going to equal 4/7. And again, I'm going to double check that in my calculator. There is a way that you can plug in e. On my calculator, it's either above the ln button or it's above the little caret button. But if you go e to the negative 0.559616, I got 0.57, which if I try to do math, enter, yeah, that seems about 4/7, and I can check that. I could even take 4 divided by 7, and if I take 4 divided by 7, I get 0.57. If I plug this into my calculator, I also get 0.57. So I know this statement is true. Check and check. Number 2, parts A and B, ask you to go the opposite way. Write the following exponential equations as log equations. So if I take a look at part 2A, the base I have is 10, which leads me to that I'm going to be using a log, versus part B, the base is e, which means I'm going to be using ln. So this time my exponent is negative 6. So I know that logs equal exponents, so I know my exponent must be over here. If I was going to write this, it's log, technically base 10, I'm going to change this in a little bit, of 0.000001 equals negative 6. A better way to write this, though, is just log of 0.12345 zeros equals negative 6, because you assume that the 10 is there, but you don't need to write it. In part B, the exponent this time is 2/3, so logs are exponents, we must be equaling 2/3. So if we're saying log base e, that's really ln. So it'd be ln of 1.947734 equals 2/3. I'm going to write that more neatly. And again, these examples as well, you could plug into your calculator and make sure. You could take log, you could literally take your calculator, plug log of 0.000001, and if you do, you should get negative 6, which I did, so check. And then you could do ln of 1.947734, plug it in, and you should get about 2/3, so that worked as well. So when you're doing your exit slip later, you might want to check like I did. Calculators are handy tools. 3. Given that $15,725 is invested at an interest rate of 4.7%, find the balance of an account after 15 years if it's compounded monthly. So I'm going to underline all the important information here. Whenever you see the word compounded, that should make you think of the equation that was in the second video for today. A equals P times 1 plus R over N to the NT. And the meanings, P represents your initial value, R represents your rate or your percent. N represents the number of times you're taking the money out per month, and T represents time. So let's think about what we have here. The initial amount that we start with is the $15,725. The R is the rate that we're dealing with, 4.7%, which if written as a decimal, you move the decimal over twice to the left, so that's 0.047. The N represents the number of times that you're taking out money per year, and if we're taking it out monthly, there are 12 months in a year, so N would be 12. And lastly, T represents the amount of time that the money has been in the account, which is 15 years. So A, or the money you're going to get, equals $15,725 times 1 plus 0.047 divided by 12 to the 12 times 15. So all I did was plug in the values that we found earlier, and now you can plug this into your calculator directly. My suggestion would be to use the order of operations and work inside out. So what I'm going to do, and I would like you to do this with me, is I would want to do this part first. You take 0.047 and you divide that by 12. I got 0.0039. Then without erasing anything in your calculator, the next thing you're going to do is add the 1. You should have 1.0039 in your calculator. Then you're going to raise that order of operations. You raise to a power before you multiply. So you're going to raise that to the 12 times 15 power, which would be 2.02. And then lastly, you multiply by $15,725. And my final answer for A was $31,781. And let's see, I got this. So if we're thinking cents, it would be $31,781.20 if we are rounding up. What if the above was compounded continuously? Now, if you see the word continuously, we are almost using the same formula, except what I did in the previous video was I realized that 1 plus r to the n, if you're using a limit, eventually goes to the number e. So if you see continuously, the equation is now PERT, P-E to the RT. So now it's the same information, but we don't have to plug in as much. The same amount of money is the $15,725. E to the rate, which is 0.047, times the time, which is 15 years. Notice that the 12 is not used at all, because when we're compounding continuously, that means that we are not worried about monthly or weekly or daily. It's literally compounding constantly. So if we plug this into our calculator, we view $15,725 times E to the 0.047 times 15. I got my final value to be $31,824. And here's again a little rounding issue, 989. So I'm going to say the final answer is $31,824.99. So what's interesting here is that if you compound monthly and compound continuously, there really isn't that much of a difference in the final values, but every cent counts, right, when you're compounding money. So, I mean, I would definitely go with continuous over monthly if it were me. All right, let's do a little connection to past videos. We would like to graph this equation here, which even though we haven't been dealing with graphing ease yet, it is still an exponential equation. So we're going to treat it like an exponential equation. The key points that we cared about for exponential was 0, 1, and then 1, the base. So this time we have 0, 1, and 1, what? Well, the base is e, and e is really a number. If we plug e into the calculator, it's really 2.718. So we really have the point 0, 1, and 1, 2.718. Now I know this is rounded, but just so we can have a general graph here. So now we want to continue consider the shifts. We are going, so if it's plus 3, we're going to the left 3, and we're going up 2. So we're going to make those changes to these points. If we're going left 3, we are changing the x value and subtracting 3. So we have -3 here, and we would have -2 here. If we are going up 2 units, that's expecting the y value. So that means it would really be 3 here. and going up 2 would be 4.718. So we come over here and plot those points. Negative 3, positive 3 is right there, and then negative 2, 4.718. A little bit higher up there. We need to think about what the equation of the asymptote is. So if we are dealing with an exponential equation, we are usually increasing, and the asymptote is usually horizontal. If we are dealing with the parent function, the asymptote is at y equals 0, but this time we are moving up 2 units, which means that the asymptote is up 2 units as well. So my graph is going to look something like this. Make those points apparent again here. All right. So what is the equation of that asymptote? Well, we are crossing the y-axis at 2, so we'd have y equals 2. Now that we have the picture, what is the domain? Well, we're going forever to the left and forever to the right. So my domain is negative to positive infinity. What is the range? We're going from bottom to top. So the lowest y value is 2, not included, up to positive infinity. And then what is the y-intercept? Well, it doesn't look like we see it on the graph, but we can find it by plugging x equals 0 into the original equation. So y equals e to the 0 plus 3 power plus 2. So we'd have e to the third plus 2, and we can plug that into our calculator directly. So if you take e, raise it to the third, I got 20.08 plus 2. So I got 22.09. So if I wrote that as a coordinate, my intercept is 0, 22.09, which makes sense why I'm not seeing it on my graph, because it is way too high up for this example, or the graph that I provided at least. Another connection to a past video. We were graphing logs in the last video. We were not graphing ln, but remember, ln is a special type of log with a hidden base e there. So if you're thinking about the key points for any log graph, the key points were the inverse of the exponent, 1, 0, and the base, 1. So we'd have 1, 0, e, 1, which is really 1, 0, and then we said on the last example that it's really 2.718. So 2.718, 1. Now if we consider the shifting, we are going to the right 3 units, and we are going down 1 unit. So if I make those changes, if I'm going to the right 3, that means that I am going 4 over here, and I'm adding 3 onto this, so 5.718. Down 1, this becomes -1, and down 1, this becomes 0. So if we plot those points, 4, -1, and 5.718, 0, cross right there. In the parent function of any kind of log, again, the graph looks like this, and the asymptote is the parent function, the asymptote's on x equals 0. So now, if it's x equals 0, we shifted to the right 3 units, which means that my asymptote is now right here. So if I go close to the asymptote and connect my 2 points that I have, my graph would look like this. So the equation of that asymptote, it crosses the x-axis at 3. So we have little x equals 3 there. The domain of this function from left to right, the first x value that exists is 3 not included to the right to infinity. The range, the graph goes forever down and forever up. So we have negative infinity to positive infinity. Something I didn't ask, but I definitely should have, was what is the x-intercept? We found the x-intercept already because it crosses the x-axis right here. So your x-intercept is the point that you already found, 5.718, 0. I'm going to write a note also that there is no y-intercept. Let me erase that. There is no y-intercept because it does not cross the y-axis at all. So I thought those would be useful for you to see using base E. And lastly, a little bit more review. Evaluate without using a calculator. Remember that logs are exponents. I think you're going to get sick of me saying that because I'm going to say it pretty constantly. So if you're looking at 6, 7, and 8, all of these are asking you to evaluate a log, which means your answer must be an exponent. So if you're thinking about this backwards, what this is saying is 4 to the what is 64. the base in this one is 2. 2 to the what gives you 1/32, because we don't know what that exponent is. 3 to the what gives you -9. Again, we don't know what that exponent is. So this first example, 4 to the what is 64. Well, I know that 4 times 4 is 16. Is 16 times another 4 equals 64? It does. So 3 4s multiplied give you 64. So your final answer is the exponent of 3. Number 7, 2 to the what gives me 1/32. Well, 2 to the 5th, or 2 times itself 5 times, is 32. So that means 2 to the -5th must be the reciprocal, because negative exponents don't lead to negative numbers, they lead to reciprocals. So your exponent that makes that true is -5. Number 8 is an interesting one, because if you think about how do you get from 3 to 9, you might be thinking 3 squared, but that's +9. You're like, oh, okay then, it's 3 to the -2nd. But based on number 7, negative exponents don't lead to negative numbers, they lead to reciprocals. So then you might even ask yourself, how about 3 to the 1/2 power? But the 1/2 power, you might remember from earlier in the course, means square root of 3. So is there any way to get -9? No, this isn't possible. And the reason it's not possible is there's no exponent rule that exists that allows you to get a negative number. Alright guys, per usual, I hope this video was helpful. Feel free to rewatch. If you have any more questions, feel free to contact me. Thank you.